Hey guys, welcome to day 2 without yours truly. Hope everything's going well, and I hope by now you have successfully completed LT1. So I'm just making an assumption that this is day 2 and that my date up here is correct in terms of being the 15th. I want to give you a quick rundown of where we're headed, all right, because your formula sheet is going to be very important today. And what I would recommend is maybe we pause this video and give you time to copy down, to the best of your ability, this picture up here, and to locate this formula sheet. All right, I don't know if yours is blue or not, but make sure it's Physical Science B formulas. And again, there's extra copies up front. And I would also want to make sure you have the practice problems for this. Okay, so 3 things. Copy this down, practice problems, formula sheet. And again, I would pause this video until all those things happen, but I am going to keep rolling. So, LT2, where we're headed in the grand scheme of things is we want to be able to predict the gravitational force when the distance changes. So yesterday in LT1, it was just good enough to say, well, if an object is less massive, it has less gravity. Now we're concerned about the distance factor. Okay, less about the mass, more about the distance. When we get into target 3, just so you can think big picture, all of a sudden we got to use this mammoth of an equation. All right, and look, it has the masses, which was dealt with in target 1, and then all of a sudden the distance, which we deal with here. So it's kind of like baby steps here. Before we do this, let's at least be able to handle this part, which is what today is about. So that picture you copied down, if you're wondering what is going on there, I like it when I'm here because I can be more annoying than I can be via video. Take a flashlight, and if we pick somebody in the front row, we shine it right in their eyes, turn all the lights off, put a flashlight right in the old eyeball. Okay, the people behind, back here, you guys can kind of giggle about it, you guys can giggle about it. For this person, that light is covering a really small area, and it is really intense. So intensity, and then a short distance covers a small space. But if either I back up or we start to notice, okay, what would happen though if this person wasn't there? So they duck down, let's say. Okay, we can cover more space. The light's still probably annoying, but it's less intense. Well, what if these 2 people duck down? We go back here. All right, people in back row who think that they're out of my sight, well, all of a sudden you can see this light too. And it may not be that bright, but more people can see it. Okay, that's what this inverse-square law thing does. Ultimately, we care about gravity, but you can't see gravity, so it's easier to think about that annoying person that shines a light right in your face if you're up close. If you guys have ever spray painted, you know there's a little bit of an art to that. If you get really, really close when you spray paint, you're going to cover a really small spot, and it's probably going to run, so you know you got to stand back to get the paint to spread out more evenly. So less intense is what we would say the farther you get away. All right, so right here on that picture, here's that one person. Okay, apparently they're happy. But as we get farther away, we cover 4 times the space. So we have doubled the distance, which hopefully you can see here. If this is 1 unit away, this you would think, well, now we're doubled, all right, so another unit, but 1 plus 1, that's 2, yet it's 4 times the space, or 1/4 as intense. So if we go out here, 1 more unit out, so another unit, now 3 times farther away, yet this is a 1/9, if you can't see that, that's a 1/4. Okay, so 3 times farther away, we cover 9 times the area, yet the intensity of the light is only 1/9. Okay, so just when we get into this gravity stuff, if you start to panic on me, just think flashlight. Okay, the farther apart we are, the bigger area it covers, yet the less bright it is, the less intense it is. All right, so this whole thing, obviously, I don't want to write in red, sorry about that. We're going to call it the inverse square law because your math teachers are fantastic, you should already have an idea of what inverse is. Okay, it's the reciprocal of something. Miss Klein is a math expert, so if I say something wrong, feel free to jump in there. So our distance is squared. So if you start to see, well, I got twice as far away here, and I covered twice the area, that's where that comes from, 2 caret 2. Remember, Miss Narker says I have to use carats. So 2 caret 2 means it turns out to be 4. Okay, so whether we're talking 4 times the area or 1/4 the strength. This I here stands for intensity. It is not cheating today. Not cheating. And I will fill mine out as well to put some steps down to solve these. So not cheating, highly recommended that you write some steps down here to be successful on this target. So I equals 1 over the d squared. That's already taken care of for you. This d is our separation distance. Okay, that d is the separation distance. So if we use another example before we get to gravity here, let's talk about that spray paint again. And I know you'd be sad if you didn't get some lens drawings. So here we go, Miss Klein. I know you haven't experienced this yet, so are you ever in for a treat? But let's say we start out, oh, we gotta have the spray paint. I don't know that that looks like spray paint, so we really gotta pretend here. But let's say we're covering a wall and you don't know what you're doing. So let's say the distance to this wall is 1 unit away. Okay, so it could be 1 meter, doesn't matter, just 1 unit. So your intensity is just coming from this formula right here, where it's 1 over 1 squared. Okay, 1 over 1 squared, which means our intensity is just 1. But things start to get a little bit different if we go a distance of 2 away. So you get the wall is now twice as far away from you. Now for our intensity, that 1 stays on top in the numerator. That's just part of the formula. That's part of the inverse idea. So you don't do anything with that. But our distance, it's the square law. You got to remember to square it. So 1 divided by 2 squared means our intensity is only 1/4. So that paint would go on 1/4 as thick, yet thinking about it, you would cover 4 times the space. So it's 4 times the area up here. And if we go out 1 more, just for fun, because this is fun, right? Distance is 3. So now, for our intensity, it is 1 over 3 squared. Sorry, 1 over 3 squared, which means it's 1/9. If we wanted to put it into words, 1/9 is thick. But remember, we cover 9 times more wall space. All right, so there's a couple things you can hopefully see, spray paint and light. So now we go to something you can't see. So what we're going to do is do 2 of the practice problems together today. So that's why you want to have this sheet, and I'm helping you make your very own cheat sheet, your formula sheet. Get your name on there if for whatever reason you are rebelling against that. Otherwise, if you do all this work and you leave it, we don't know where it's supposed to go. All right, so you got to take it out of that plastic sleeve if you haven't figured that out yet. But we're going to do 2 of these. We're going to do number 1, and we are going to do number 3, okay, because those are 2 slightly different types. So we're going to do 1 and 3 together, and then once you're done listening to me, you will complete the other ones and show Miss Klein that you are awesome. All right, you'll show her your answers to be sure you're doing this right before you take that learning target, before you take LT2. So have some faith in me right now, and we're going to write some steps out. I know you don't know why we're writing out these steps, but your predecessors have taught me a few things, and this is the easiest way. All right, this is what they tell me works for them. So for the inverse square law, make sure you don't overlap these 2, so I'm going to put a line there. It is a 3-step process, and I'm going to put it up here. Okay, the first one, divide the larger distance by the smaller distance. So step one, maybe I'll even put it here, there. Step one, divide the larger distance by the smaller distance. It's the first thing you want to do because it's the square law. So step two, you want to square the answer. Remember, caret 2, square the answer. Your third step depends on something. It depends on if in the problem you're getting closer together or farther apart. So if you're getting farther apart, you take the original force, so it's the force divided by that answer, and when I say that answer, from step 2. If you're getting closer together in the problem, you take the original force that's given to you, but you multiply it by the answer in step 2. If you follow those 3 steps, this is cake. Okay, it's easy. And if you write these 3 steps down, you don't have to memorize it, because we know memorizing is evil. All right, so make sure you have those. And you might still be writing. I have no way of knowing, so I'm just going to sit here staring at the wall. All right, a little bit of coffee there. I'm going to have to move this, and we are now looking here at the LT2 practice problems. So get your name on there, claim it. And number 1, I'm not going to zoom in because you have them in front of you, but it says, if the gravitational force between 2 objects that are 15 meters apart is 100 newtons, what would be the gravitational force between the 2 objects if they are 45 meters apart? So you got to look at the units. We've got 2 distances. Newton we mentioned a long time ago, but even yesterday is a force. So we're going to use this inverse square law to solve this. So you just go to your steps. Take the larger distance and divide it by the smaller. So divide the larger by the smaller. So it's going to be, I'm going to write it out like this even, 45 meters divided by 15 meters. And that answer is 3. Okay, that's our first step. Our second step is to square that answer. So 3 squared, just in case. And again, this Klein can help with this very easily. 3 caret 2. Okay, 3 caret 2 is 3 squared. That gives you 9. And then the third step just takes a tiny amount of thinking, not a lot. We start out 15 meters apart, and we end up 45 meters apart. So we are getting farther away, 15 compared to 45, all right? We're getting farther apart. So what we said is if we get farther, we take the force that's given to you in the problem and you divide it by the answer. So we take the force from the problem, 100 newtons, we divide it by 9. And so I got to click away here, 100 divided by 9 gives us an answer of 11.1. It should say within Moodle to round to the 10th, which means remember, keep the 1 to the right of the decimal. And so you would type in 11.1. It is newtons, but you don't type in the letters. You would type that into Moodle. You would get it right. You would be happy. Now the other one I said we would do is number 3. Okay, it's the same process. We just do a little bit different thing in the third step. All right, so first step, you're looking at your blue sheet. You divide the larger distance by the smaller distance. 20 meters is farther than 5 meters. So 20 meters divided by 5 meters, answer is 4. Second step, on your formula sheet, it says square the answer. So 4 squared. Probably don't need a calculator, but if you do, 4 caret 2. Answer is 16. Third step, we're looking at the blue sheet now, or the whatever color yours is. Take the force and multiply it by the answer. And we know that because in this problem we got closer together. We started out 20 meters apart and now we're only 5. So we take that original force, which is still 100 newtons, so 100 newtons, and we multiply it by 16. Because this force should get bigger. Okay, we're getting closer together. The closer you are to something, the stronger the pull. So we go 16 multiplied by 100, which is 1600 newtons. You would type that into Moodle. Now if you're willing to slow down, like after you get an answer, like double check yourself and like go back through and say, okay, I got farther apart, so is this force smaller than the original? Because if that's bigger, you know you're wrong. If you get farther away, it's got to be weaker. If you get closer together, it's got to be stronger. So the closer you are to an object, the harder it pulls. This may seem really simple, and if it does, that is fantastic, because this may not be so simple. So we got to understand this denominator, this bottom part, before we can throw it all together. All right, and I think that is it for me. Good luck.